Hi, it's Mr. Baumgarten here, and today we are making the classic Flappy Bird. This has come about through a conversation I had with some of my students earlier today, as a matter of fact, where it kind of dawned on me that students doing IGCSE computer science or diploma computer science don't really get the chance to learn how to do graphics and game systems in those courses. And so you might have a good understanding of variables and if statements and loops and writing functions and perhaps even objects and things like that. But the courses themselves don't have time in the syllabus to introduce you to graphics. And so today, and when the question was asked, well, I wouldn't know how to make Flappy Bird, I thought, well, let's fix that problem now, shall we? So I will have a few assumptions moving forward with this tutorial, and I will put all my code on my GitHub. You can see the address here. It's not published here yet because I haven't made it yet. We're about to make it together, but this is where it will be, and I'll put the link in the video comment description as well. But I will assume you've got a basic understanding of core programming skills, variables, selection statements, so if statements and things like that, repetition, loops and functions, and that you've got Python installed on your machine and Visual Studio Code with the Python extension installed on your machine, and Pygame installed, which I'm not actually sure if I've got installed globally, so I might actually also just quickly do that with you. So this is that README file that I've got there, and as you can see, my folder is currently empty. I do have a media folder, so this is what I have organized ahead of time. I've got the graphics and the sound effects files that we will need, and these are also on the website. They are all there for you. And so that is all that we're going to need, and we can get ourselves up and running. So if I just show you what we've got here, we've got the background, we've got the base, we've got our Flappy animation, we've got the pylons, and we've got the sound effects there as well. So when it dies, there you go, and so on. All right, let's not waste any more time going through the folders. You'll hear all the sound effects when we play the game after all. So I have my Visual Studio Code open. Let's create a new file, Flappy Bird .py. All right, here's my Python file. Now let's just double check that I have the Pygame extension installed. I'm just going to install it globally, just for simplicity's sake. So terminal, new terminal, and pip install -- user you'll need if you're not a Windows administrator on your machine. It'll just be easier. Pygame. Okay, and it's already on my machine. So if it wasn't, that would then install it. So once I've done that, I can just exit out of that, and we're good to go. So now that I know Pygame is on my machine, so Pygame is the Python graphics library that we're going to use for this. It's fairly commonly used and quite well supported in Python. So we are going to import the Pygame library. I'll just move my microphone. Okay, and while we're at it, we're also going to import from pygame.locals. We're going to import everything, so the star. Okay, and our first command is just going to be pygame init to initialize the Pygame system, and we want to create a screen that we are able to draw on. Now here's the question, what resolution do I need for the screen? So let's grab here's my background. What size is this thing? If I right click on this PNG and go to properties, I can see that this file is 288 by 512. So how about we go for the same? We make our game the size of this background file, 288 512. Window is equal to pygame.display.set_mode two sets of parentheses, 288, 512. All right, so our width and our height. And so we're creating a window that we're going to be drawing our graphics on. And then we need a clock system for figuring out our drawing onto the screen. So pygame.time.clock with a capital C, open close parentheses, and that creates our clock for the game. All right, that's the core of getting Pygame installed. So then I'm just going to create a few comments for the different parts of the game that we'll structure together. So we're going to declare our variables, our global variables first, and then we are going to run our main game loop. Now the way Pygame works is it generally works off one big loop that runs 25 frames per second or however much you set it up, and then inside that loop it's your obligation to then update the screen for what you want to have happen in that 1/25th of a second, so as each frame of the game runs, and to also check events that might have happened, such as movement on the mouse or a keyboard press. So while not finished, so while the game hasn't finished, we're going to keep going into our loop. And so the first variable we're going to need is finished, and we're going to set that to false. So we haven't finished. Then we're going to process keyboard and mouse events, and then we will perform our game logic, and we will then draw our graphics onto the screen, and at the end of it, when the loop is over, the game is over. Right, and so at that point we will just do pygame.quit, which will close the graphics system in Pygame. In terms of drawing graphics, the two main commands we're going to need here initially are pygame.display.update. This will, whatever things we draw to the screen up the top here, they don't actually get drawn, they kind of just get buffered, they get saved into memory and don't actually get drawn onto the screen until we do this display update command. And then we're going to run our clock and tell it to tick for 1/25th of a second. All right, so, and we'll add more stuff to that in a little while. Let's process keyboard and mouse events. Okay, so the Pygame system gives us an event queue of everything that has happened in that 1/25th of a second, which Pygame event get will provide to us. And so the normal way of doing this is to just simply do a for loop through it. So for every event that is inside the queue of events that have happened in the last 1/25th of a second, we want to process them and see what they were. So for instance, if the event was a key press, so if the event has a type of key down, so that means we've pressed a key, then we might want to check to see what the key was that was pressed down. So if the event key is equal to, and this is where you need to know the codes. Now these codes are embedded in the Pygame locals file. You'd be able to find them on the Pygame documentation website. So k_escape, so that's if I hit the ESC button up the top left of most keyboards. All right, so if I hit the escape key, how about we just end the game? So we just set finished to true. All right, we're going to bail out of the game. Other than that, what else does Flappy Bird need? It just needs something to cause the flap, right? The upward motion on the wing. So we can either do like a space bar, or we could do a click on the mouse. How about we do both? And so let's do if event.key is k_space, then let's have a variable called flap, and we'll set that to true, which means I'm going to come up to the top and create a variable called flap and set that to false. Right, and to show you how to do it with the mouse, if event.type is mouse movement, and I need to just quickly remind myself what this is. I do have on my website, I've got here some Pygame reference notes, so I'm just using this to remind myself of some of the core functionality. It's been been about 6 months since I've done much Pygame. So there is mouse motion. So I think it's just mouse. I don't actually. Oh yeah, anyway, mouse button down. All right. So if the mouse is button down, then let's call that flap as well. So either the space press or the mouse click will initiate a flap. Very good. Okay. So let's start drawing. Okay, so we need to draw our background. Now this is known as blitting, is the game jargon term for drawing an image onto a graphic section on the screen, basically. So what I'm going to do is we'll use a few variables to load up all of our different images. So let's start by loading up the background, and I'm going to use, because it's a constant, it's something that's not going to change, I'm going to use all caps. It's entirely up to you. Pygame.image.load, and then inside the parentheses I put in my file name. Now I've got mine inside a media folder, so I need to tell it where the folder is relative to my Python file. And it's just background.png. In Visual Studio Code, you can actually just right click on this and say copy relative path, and then paste from that straight into there, although you need to change the slash back to the other way, or do a double slash, just change the slash. And then I'm going to convert the alpha channel, just in case. I find it just works easier if I just do that all the time. I won't worry about getting into the graphic reasons behind it. Okay, so that's my background PNG. Let's get my, so that's the base image. All right, so well, let's check that this is working first, shall we? It doesn't do much, but if I save it and click run, okay, so here's my Pygame window, and it is blank, a black window, and that's because I've loaded this image, but I'm not drawing it onto the screen. So if I hit the escape key, it does exit though. All right, so let's make sure that we draw our background onto the screen. So in my draw graphics section, what I'm going to put here is window.blit, and I'll put in the name of my image variable, which is background, comma, and then inside another set of parentheses, these are the coordinates of the top left corner of where of the image. So I want to put the top left corner of the image into the coordinate location 0, 0, which is also the top left corner of the screen. So Pygame screens work, yeah, that top left corner is 0, 0, so the x-axis is 0 on the left and increases as you move right, and the y-axis is 0 on the top and increases as you go down. So it's upside down to the Cartesian plane on the y-axis. Right, now the other thing I will put here, is I'll do a window.fill 0, 0, 0, and that just paints black over the entire window. So that will clear everything off, and then we're going to paint our background over the whole thing. So that's probably redundant anyway. And then we will draw our base, our Flappy Bird. So that's the background. We need to draw the base. We need to draw the pillars, and we need to draw the Flappy Bird. And that'll be all we need to draw, I think. All right, so now if I load it up, okay, there's my background. Fantastic, that works. All right, let's add the base to it. So the base is this thing here. What's the dimensions on it? Let's go back to Explorer. I closed it, didn't I? That'll be right. Flappy Bird Media. Base is properties, details. Okay, so 336 by 112. Well, that doesn't make sense. It's wider than the entire Flappy Bird. We don't need to draw the entire width. Let's just go with the 112. So it's 112 high. So if we draw it from 400 pixels down, it will fill up that bottom part of our screen, and it'll go over width, but we won't see it because it'll just draw it off the edge of the little screen. All right, so let's just do base pygame.image.load. All right. Convert alpha. Okay, so let's draw the base. Window.blit base. All right, so x0, y is 400, and if I run that, all right, I've now got the base. That's the ground, which we don't want to crash into. Oh yeah, and I haven't made my little X box, close box work. We can do that, but let's not worry about it for now. All right, now we need the pillars. We have two of them. Well, we've got one here. We've got one pipe, and we're going to need to draw two, one of them rotated around. All right, so let's just load in the original pipe image. Convert alpha, okay. And then we need the rotated one, which I need to remember how to do that now. Flip, that'll do. Okay, so that pipe is the one that needs to appear on the bottom, right? Because there's the top of the pipe there, and then we need the other pipe that comes down from the top. So we'll call that one bottom pipe, and then we'll make up another one called top pipe. All right, and we will do Pygame.transform.flip, and we want to flip the bottom pipe false true, I think. Let's test this. One of these is horizontal and one of these is vertical. I can't quite remember. I think I've got it the right way around. Let's test it and see. So if we're going to need coordinates for where we want the pipes to appear. So let's just do pipe, and we can use so let's use the X value. So at the moment, how about we're 288 wide. So to test it, let's just make it 200 across, so most of the way towards the right. And then use the Y value for where we want the gap to appear. How about we do it for that? All right, because we need the two pipes to be kind of moving up and down with a fixed gap between them, I think. Let's just put 100 here and see if I can get that to work, and then we can adjust for it later. All right, so the first value is the X location of both pipes. and then the Y location of top of gap. That's what I'm going to do for that. Comments come in really handy. Okay, so the pillars, window.blit. So the top, well, yeah, pipes or pillars? Pipe is the name of the PNG. Let's just call them pipes. Anyway, so the X coordinate, well, that's going to be, what did I call this variable? Pipe. Pipe. So that the X coordinate is the first one, and then the Y coordinate will be, I need the top, I need to give it where to put the top of the pipe. But if this is the top of the gap, then it's the bottom of the top pipe. I hope that makes sense. So I need to know how high that pipe is so I can subtract it off of this value. So it's going to be pipe 1 minus whatever the height of that top pipe is. And to get that, I can just look up the PNG. Let's just do that, shall we? I know there is a function that will do it for me, but anyway. Let's get the PNG. This thing is 320 pixels high. So I need a minus 320 off what I've got. And I'm kind of a stickler for pipe height, using variables for things that could change. So let's just put up here pipe height and set that to 320. So that if I change my pipe images, I've only got to change it in that one place, and the rest of my code will automatically work. All right, so that'll draw the top pipe, and then the bottom pipe, window dot blit bottom pipe. All right, and it will appear at the same X location, and then it'll be that location, which is the top of the gap, plus we need a variable that's going to be our gap. And then we can actually also change it within the game. We can randomize it. Every time pipes appear, we can change the gap size. So pipe gap, let's start it with 100. Okay. Let's see if that works. Okay, there you go. We've got some pipes. Let's make the pipes move, shall we? I'm going to keep doing that, aren't I? So let's create a variable for pipe speed, because then we can also change that. We can speed it up, slow it down if we want later on. So how far do we want it to move per frame? So every frame is 1/25 of a second. Let's just say 10 pixels to start with. All right, and so here in my game logic, so if this is the X location, that's what I want. Right, and 0 is the left-hand edge, and then it increases as you go right. My pipe, on the other hand, starts on the right, and I want it to move left. So I want to subtract off of this number by the pipe speed. All right, and so when I run that, okay, it does that, and it disappears off the edge. So what I need to do is, if it has disappeared off the edge, so which means if it's become less than negative, now it's not 0, because otherwise this will trigger as soon as the left-hand edge of the pipe hits the left-hand edge of the screen. But I want the whole pipe to go past the screen before we do trigger this. So I need to subtract for the width of the pipe, which was what? 52. Okay, so that needs to be minus 52, which I should just put here, pipe width minus the pipe width, negative pipe width. All right, so once it's pipe width is 52. Like I say, there's a function that gives me the width and the height. I just can't remember it off the top of my head. Once it goes past the edge, then let's push it back to back to this width of the screen, right, which is my, these should also be variables, shouldn't they? Screen width is 288, screen height is 512. So that can go in there, that can go in there, and then screen width comes back down here. Reset it back to the screen width so that it will just keep on looping through and reappearing like that. Fantastic. Now when it reappears on the other side, I want to change how high or low the gap is, all right? Because that's the whole point of the game, is that the pipes move. So when this triggers, all right, is where it's going to draw it back, move it back to the right hand, off the right hand edge. That's the time that I want to change the location of the gap. So I'm going to put a random number in here, which means I need to import random, bring in the random number library. All right, I want to give this a random integer between, let's say, 50 and screen height minus 150. So give myself a bit of a range through which to, and while we're at it, let's change the gap. So pipe gap, let's make that a random number between 100 and 200. Let's see what this does. There we go, the pipes are moving and this gap between them is different each time. Fabulous. Now all we need is our bird, and then we need to that was a little too high. A couple of little bugs to sort out later on. Yeah, we need the bird to flap. We need to detect the collisions. We need to add the sound effects. We need to get a score going. So this is not going to just be a quick 20-minute video, especially since we're already up to half an hour. All right, let's keep going. Let's get the bird. So what have I got? Where's my bird? Here's my Flappy Bird animation. I've got my 3 little Flappy Birds in here. Let's load Flappy Bird into the system. Okay, let's make our bird. So bird pygame.image.load, and I'm going to copy in our Flappy Bird animation. Okay, and then we are going to draw, so we'll need some coordinates for our bird. And I can do lowercase here because Pygame is, well, Python is case sensitive, so uppercase bird is different to lowercase bird. It's probably not good practice, but anyway, right now we're doing it. All right, so let's just draw 50 pixels in from the left, 250 pixels down from the top as a starting location. We can adjust that later on if we don't like it. All right, now to draw the bird. Now you would have noticed here that there's actually 3 different images of the bird. This is the animation, so the wing flap. You can see the wings are down, wings are up, wings are horizontal. And so we want to draw one of these at a time and rotate through them. We'll just draw the bird to start with first. So window blit bird at location bird. We can just do that because it's already the equivalent to open parentheses, put in the 0, and then put in the 1, and then close the parentheses. We're just providing the array of the 2 values. So that should work. Okay, so there's our 3. Now we only want 1 at a time. And so the way we do that is we provide here 4 more numbers. We need to give it the image width, the image the X and the Y location within the image that we want to start our crop, and the width and the height. So we're always going to want, as in, all right, so these 4 coordinates allow us to, within this image, to draw a square of this image. And so I need to specify the top left corner of my square and then the width and the height of it. So the width is always going to be the width of the thing, whatever this is, and the X coordinate is always going to be this left hand edge. What will change, and the height is always going to be however high one bird is, because it's going to be the same for all 3. So the only value that's going to change is going to be the Y. Right? Am I going to draw a square that starts here at the top? Am I going to draw a square that starts here 1/3 down? Or am I going to draw a square that starts here 2/3 down? Right, and so if I take a quick look at my image, it is 34 pixels wide, 72 high. So 72 divided by 3 is 24, so each bird is 24 pixels high. Well, let's have a go at drawing this thing. So if let's just try getting the first one up. So 0, 0, the top left corner of the image, and then I want to draw a width of, what was it, 34, and a height of 24, and that should give me 1 bird, which it does. And now I'm wanting to move between the 3 different birds. So the easiest way to do this is, let's just make a variable, bird animation count. I don't know, that's a long name for a simple variable, but anyway, we set it to start off 0, and this just needs to rotate between 0, 1, 2, 0, 1, 2, 0, 1, 2, between the 3 images. And then this Y location here will be that, so it will be that bird animation number times by 24, so that when it's 0, then multiply by 24 and give us 0. When it's 1, multiply by 24, it'll give us 24. When it's 2, multiply by the 24, it'll be 48, and so it'll give us that 3rd bird. And then after the 2, we then need to cycle back. And so what we want is every frame increase this variable by 1, but after 2 we then reset it back to 0. Now we could just do increase it by 1, and then if it's bigger than 2, set it to 0. Sure, we could do that, or we could just do +1 and get the remainder when we divide it by 3. When you divide a number by 3, the remainder will either be 0, 1, or 2. So that should give us a nice flapping bird motion. Look at that. All right. Okay. What do we want to do? Fall for gravity. And well, maybe we should do a jump first, because otherwise we're just going to fall straight off the screen and not. All right. So we've got this variable called flap. So when we set flap, let's have, so gravity starts off high and then gradually becomes less until we start falling again. So let's just have a jump variable and set it to 0. And so the Y location of our bird, the Y location is position 1, that decreases by whatever's in our jump, because we need to subtract off our Y to move up. And if the jump number is greater than 0, then we're going to subtract, I don't know, 5 pixels per frame. Let's try that. So and so then if this flap variable was true, so if flap, we are initiating a jump, so let's start jump off at 50 and then turn off the flap so that we don't keep triggering it again the next frame. Okay, so every frame we want to change our y coordinate by whatever's in jump, and we're gradually going to reduce whatever's inside jump until it's 0, maybe. Alright, if I hit the space bar, and we've flown right off the edge of the screen. Way too much jump going on there. Of course, because that would have been 50 pixels, then 45, and then 40, and then, yeah, okay. So let's change this to 20. Let's see what that does. Okay. Alright, so we're going to have to tweak it. But you get the idea. And we can reduce the amount. That might be too much. We'll reduce the amount that gravity. Oh, that was a nice effect. You could tell that it slowed down a little bit. Okay, let's get some falling motion in. All right, so we just want to fall automatically if we're not jumping. So here, actually, instead of just if it's greater than 0, if it's greater than -10, so we can always just be falling. Oh, how much maximum fall speed do we want? Probably want a little more maximum fall than that. It's not too bad. 20 is probably going to be too much. Yeah, that's. I mean, you adjust it as you like. Make this number smaller, and it'll decrease the this rate at which gravity and the jump changes. Which will make it a little more manageable. Okay, that's enough for testing purposes. We just need collisions now, and scores and sound effects. What's my clock up to? 40 minutes. Not too bad. Okay, collisions. Okay, so top pipe rectangle is just going to be top pipe get rectangle, where the top left of it is this, and that will give me a rectangle object. This is where you just need to learn how to read the documentation. That's where all of this has come from. I certainly did not have this memorized. Someone's written this code, which I'm very grateful for in Pygame. And then, yeah, you just have to study what they've written to go with it. All right, so I've got top pipe, bottom pipe, bird rectangle is going to be bird.get rect, where its top left actually I'm going to just draw a custom rectangle for this one. So the X and Y location is going to be these things. No, it's going to be here, bird 0 and bird 1. Bird 0, bird 1, and then its width is 34 and its height is 24. Because if I use the get rect function, it was going to give me the full height, and I only want 1/3 the height. It's just easier to just create a custom rectangle. So I've got 3 rectangles. How can I detect if I have collided with any of them? So if the bird rectangle has collided collide rectangle with bottom pipe rectangle, or it's collided with the top pipe rectangle. All right, then we have a collision. And so let's play the dead noise, I guess. Which are the different sound? What's the difference between die and hit? Point, swoosh, wing. We need. Is it? Which one plays? I should be playing one of these when I'm flapping. But anyway, let's load in our sounds. All right, so our sound effects. I'm assuming we just die if we hit the pipe. Die. What a variable name. Pygame mixer dot sound capital S. All right, and that's in media die dot wav file. And then down here I can just say die dot play, and then quit Pygame, I guess. Let's just see what this does. Yeah, okay. Can I even get through a pipe? Oh, come on. Yeah, through one of them. Okay. I'm guessing that should actually be the hit sound, because that doesn't sound right. Let's see what the hit sound should be. Yeah, okay, and you may think that sounds a little odd, and that's because we're actually initializing it more than once, because we're hitting it several times, as several frames worth of movement as we pass through the pipe, and every frame we're re-initializing this. So anyway, okay, let's what do I want to do now? Okay, let's add our flapping sounds to it as well. What's the difference between wing and whoosh? And then point is if we make it through a pipe, I'm guessing. So, all right, let's just load these all up. Wing, Pygame, mixer dot sound, media wing dot wav. And let's do the swoosh one as well. I can't remember the difference between these. Swoosh. All right, so if I'm launching a flap motion, do I swoosh or do I wing? Let's see what this does. All right, yeah. There's nothing quite like sound effects to make a game come to life. Let's just see what wing does. All right. Is there a way to tell if the sound is already playing? Pygame mixer sound already playing. Let's just do a quick Google and see if I find something here. Check if a mixer channel is playing a sound. Yes, I can tell if it's busy. Excellent. Okay, so here, so that we don't keep playing it over the top of each other, if Pygame mixer channel 0 get busy. So I guess if it's not busy, then we can make it busy by playing it. Let's see what that does. That's better. Okay. Now, so I think what happens is we have a few lives. We hit it and we get 2, 3, or 4 attempts or something, and then we die. So let's create a variable called lives and set it to 3. I'm going to go through them so quick, but anyway, I can program games, I just can't play them. All right, so when this happens, this will also be a nice way of making sure that we don't deduct more than 1 life for going through the same pipe. Well, because actually, if this happens, if we collide, so lives -1. If lives is 0, then we need to end the game, which is what do we call that? Finished. Finished is equal to true, and we can die.play. And when this happens, we want to reset back to reset the bird back to its starting location. And we want to move the pipes out the way. Move them back to the beginning. So where's our pipe reset happens here. But let's give ourselves, if we're resetting, let's give ourselves a second before the pipes start reappearing. So instead of moving it to width, let's make it even further. And so if the pipes are moving at what speed? Pipe speed. Well, so if we times that by 25, that'll give us 1 second of time before it'll, because it'll move at 1 second, 25 frames worth of movement off the edge of the screen. So it'll take a second before it reappears. So that gives the player a chance to reset after they've died. Well, hit. Let's see if this works. Yeah. Oh, that's nice. So if I get through a pipe and then, yes, I had 3 attempts. Let's give myself some more lives. I didn't get the sound effect. Oh, that'll be because it's doing the swoosh movement at the same time. So we probably don't actually even need this because by moving the pipe straight away, that avoids a second collision happening in the same, for the same 2 frames of collision for the same pipe. See, it moves straight away. Yeah. Okay. I'm going to change this gap size to between 150 to 250, make it a bit easier. And also let's make the first pipe also appear. Was this X and Y? So let's make this also appear a little bit off screen, so we have a bit of time at the start of the game too. There we go. Hang on, there we go. That's what I'm talking about. I can get through those gaps sometimes. Okay, the last thing I'm going to do is make it tell us how many lives we've got left, because otherwise this video is going on way too long. Let's create a variable for a font, Arial, and this is just Pygame font system font Arial, and we set our font size 40 pixels. 40 will do. All right, where we want it to appear. Now this is like a stack of cards. So this is the first thing that will appear, and then this will get drawn over the top of that, and then this will get drawn over the top of that, and this will get drawn over the top of that, and so on. So how about we put it just after the background and base, but let the pipes or the bird draw over the top of the writing. So if we put it here, all right, so the label, we need to create a bitmap image of the content of the text. So we use, the font has got a renderer built into it that does this, but we need to give it a string rather than an integer. So I'm going to use the str to convert lives to a string, and 1 to turn on the anti-aliasing, and then a color code. Let's just make it white, and then we blit that onto the screen. So the label, at what location, let's just put it in the top left corner, so 5 5, and there you go, there's my 5 4 3. Oh, come on, I almost got through that one. That one's not going to happen. Yay, I got through. Oh, no, there we go. Okay, we're not getting the die sound because Pygame quits before it gets to do it. I wonder, can I just put in a time sleep for 1 second and let it do its thing? Or is that going to not work? Oh, come on. I got through one. Anyway, there we go. It's a little rough around the edges, but you can fix it up from there. It gives you an idea of how to do some Pygame work. Basic Flappy Bird game for you. I will upload it onto the GitHub page. But that's not... Oh, look at that. Just under 100 lines of code. That's perfect. This is Mr. Baumgarten signing out.